Believe it or not, that's supposed to be lined up with my coordinate system. So as I laid out that coordinate system, something might not have been right. And so if I type plan, as I laid out that plan coordinate system, somehow it looks like it's shifted from where it's supposed to be. So I can go back to UCS world, type in plan. I can do my V point, 1, 1, 1. I'm back to here, and now I'm back to where I thought I wanted to do, and we're going to try it one more time. I am going to use my navigator here, which I somehow just lost. There it is. I am going to pan. All right. And you start to see how some of this stuff flashes back and forth to get rid of all the kind of extra graphics it's carrying around. So I'm going to type now pan, kind of shift over here, and I'm going to try that again with this bit right here. So I'm going to first and foremost, I'm going to erase that line. I am going to say UCS new 3 point. We go from the end of that. I'm going to go near to this, and I'm going to go near to the edge there. And if you notice, when I did it that way, I can see the icon is in the right spot, which means now I can say UCS, save, white 1, replace it yes, and then say plan. And now I'm looking down directly on my user coordinate system. Now, finally, as I said, I was introducing this to you so you can keep track and learn about unit vectors. Direction of user coordinate systems is stored a number of different ways, but primarily for direction, it's based on the unit vector of the z direction. I think of the x and the y directions, the x and the y unit vectors in the new coordinate system as seen from the world coordinate system. So as I type UCS here and I put question mark, and what I want to point out here, it doesn't always give you the choices, which is unusual in AutoCAD or Civil 3D, but it does not give you all the choices here. So by putting question here, I'm going to give it a list, and you can see that list here of coordinate systems. The origin is at a certain point, that is your translation, and then your rotation is shown by 3 vectors, an x vector, a y vector, and a z vector. I'm going to point out that in fact we're going to do some cross products of these unit vectors to see that the x cross the y is the z, the y cross the z is the x, etc. So you see here even the format of how AutoCAD is storing points in a list. In other words, the x, y, and the z. This is the way it's always been done. You might not have seen it, but you see here the format of the unit vector. These are showing you, each of these coordinate systems that is laid out is showing you the origin in the world coordinate system, and then from that origin point, a vector, basically, that goes from the origin to the x-axis, a vector that goes from the origin to the y-axis, and a vector that goes from the origin to the z-axis. So the fact that you see these numbers floating around 1, right? They're all going to be less than 1 because unit vectors are of unit length 1, and these unit vectors are describing lambda, if you would, for the x-axis vector, the y-axis vector, and the z-axis vector in the new coordinate system. All right, that's 15 minutes. You can slow it down. What you want to get out of that here is that you best make coordinate systems using 3 points. UCS new 3 point, so you can really see what you're doing. The second thing you want to realize is that immediately after doing a UCS, if it's something you're going to use, you should save it and give it a name. You should then check plan or type plan to make sure that you have established the unit, you established the coordinate system as you should have. Coordinate systems are stored using vectors. The unit vector in the x direction is the I. Unit vector in the y direction is the j. The unit vector in the z direction is the k. Of course, these are all tied to some coordinate system. We're learning in all classes all the way up through to establish our coordinate systems right away. We definitely do it in AutoCAD, and we kind of keep you from doing it until more advanced classes. I may reframe that a little bit in my classes as I look more and more to the world of 3D as something that you really are not going to be able to avoid at whatever level you're at. We still draft flat 2D. You still think 2D in the field by breaking things up into plan, profile, and cross-section. However, you have to start to realize how these coordinate systems work together. We learned a couple of toolbars. Anytime there's a lot of power, pull these over here in AutoCAD, you're going to have the 1 and the 2. So you've got, see, losing my cursor here, don't like that. You've got the UCS1 and the UCS2. You've got all kinds of pull downs for UCSs. Hit enter to continue. If I want to change my coordinate system, I can pull down to a different coordinate system. It's not changing the view, you see. It's not changing the view. And what you'll see later, it's going to be problematic when you start using views. And I'm going to hit a right click here, bring up the view toolbar. So here, if I click in top, I presume, right, that top view is going to be the top view perhaps based on the coordinate system I'm in. So it's going to get a little bit confusing unless you very proactively just use plan for your top view. All right, I'm going to have to cut that into 2 videos. This is a review of user coordinate systems. There are other ways to do it, I know, and you can use those those ways. I do want to point out that with coordinate systems, UCSs, once you get solid models, grabbing the face is not a bad idea, but I still would really, or grabbing the z-axis is not a bad idea, but I really encourage you to master the 3-point, especially, and I'm going to do this finally to finish up my 20 minutes, especially using something called point filters, which exist in Civil 3D in some form and in AutoCAD. If you really want to get the location of something in the X, Y, and Z, you can strip out those components, if you would, of the location vector R, the position vector R, by using a point filter. So to do that here, I'm going to go ahead and go back to UCS World, type plan, and I can go ahead now and type in vPoint 1, 1, 1. Again, I don't care how you manage around, but if you're learning vector math, it's a good idea to start keeping track. So what I can do here is if I want to draw a line from the X and the Y of the corner point there to the Z point of the corner point there, I can do it this way. I'm going to take line, I'm going to go shift right click, point filters, the X, Y, shift right click, the end point of that. And then I won't need the Z, shift right click, point filters, the dot Z of, let's say I'm going to do the yellow one, of the end point of that. And what I just did is I drew a point that was directly in the X and Y plane, or X and Y location of that, but a Z location of that. Especially when you have 3 viewports up and you can start pulling locations off of one or the other, that makes it really useful. I can now go perhaps shift right click, point filters, the X, Y, shift right click, the endpoint of the green one, shift right click, point filters, the dot Z of the shift right click, the endpoint of the white one. And if you notice there, it just drew this line in 3D space. All right, that's 20 minutes. UCSs, a little bit about views and plan view, and we'll call it a lecture.